Hello everyone, and thank you for tuning in. My name is Shlomi Noach, and this is Vitess Online Schema Migration Automation, a 30-minute session at Percona Live EU 2020. And I'm an engineer at Planetscale. I'm the author of Orchestrator, gh-ost, and other tools, some of which are very relevant to this discussion. Planetscale is a young company based in Mountain View, though we have employees all around the world. We author Vitess, and we also offer Planetscale DB, which is comes in two flavors. One is the cloud offering, which is a managed database, and the other is a BOK, bring your own Kubernetes. We will install Planetscale DB on your Kubernetes clusters. Sorry. And this session is really about Vitess. So Vitess is an open source database clustering system for horizontal scaling of MySQL. It is known, usually referred to as a sharding framework for MySQL. Or is it? We're going to revisit that definition. Vitess is an open source CNCF graduated project. It's not owned by Planetscale. We're major contributors, but it enjoys contributions and maintainership from the community, from like companies like Slack or Square, Pinterest, Nozzle, and others. And this session is about online DDL, but it's imperative that we understand a little bit about Vitess architecture. So if you will consider a simple replication topology, the first thing we put is VD tablet. This is the first component we introduce, which is a daemon, or if you come from the world of Kubernetes, it's a sidecar to MySQL, which usually sits on the same host as the MySQL daemon and can control either the daemon, like starting and stopping it, or can interact with the MySQL server itself. And in production, you will have multiple clusters, so one tablet for every server. And the next component we introduce is VD-Gate, which is a smart proxy. It speaks the MySQL protocol. In fact, it impersonates as a MySQL server. It looks to be a monolith MySQL server, and you will connect to VD-Gate, or your apps will connect to VD-Gate, and VD-Gate will route the queries to the underlying tablets, further relaying the queries to the backend MySQL service. In reality, there's many VD-Gates for scale out and high availability, but we will be content with one for our discussion. And so you have multiple clusters, you have different schemas and different tables in these clusters. Some of these clusters may be sharded. When your app or your user connect to VD-Gate, how does VD-Gate know where to route the query to? And so your user will use a specific schema and will operate on a specific table. So by using commerce, VD-Gate infers that either of these first two clusters are relevant to the query. And when the user says select star from orders where customer ID equals 4, VD-Gate is able to infer that customer ID 4 is only present on shard 0. But where does VD-Gate get that information from? So while your applications may use MySQL for the backend state, Vitess uses a distributed key value store for its state, and that could be implemented by etcd or Zookeeper or console. We call it the topology, and the topo persists such information like which schemas we have, which cluster contains which schema, which servers are involved, what does the topology look like for each cluster, what's the primary, what are the replicas, etc. What are pending operation. And the last component I would like to introduce is VD control daemon, which uses topo to run such operations like resharding or planned takeovers, reparenting, etc. It's a daemon. It also serves API, and it will be. We will see shortly how it becomes useful. So that's the general overview of the Vitess architecture. And at the end of this session, we're going to reveal the mystery card. So if you're online and using the Percona Slack channel, my colleagues will post a question right now asking what is behind the mystery card, and please feel free to respond in a thread. Anything I say from this point on until the end of the presentation contains, anything I say or don't say contains a hidden truth. There's going to be an underlying truth which we will reveal later on. So finally, we get to schema migrations. And I guess we are all aware of the problems with schema migrations, right? Ideally, we would just want to run some alter table, but with MySQL, an alter table is mostly blocking. Even with online DDL, InnoDB online DDL, it may not be blocking on the primary, but blocking on the replicas. And it's greedy in resource consumption. It can starve your production traffic, and it's uninterruptible. And well, we know this story. That's why we have Facebook online schema change, or PD online schema change, or gh-ost as alternatives, as utilities that mimic the behavior of alter tables. And of course, you will need to install them and formalize the command line and provide the correct command line options. And that's something that is, of course, outside the MySQL zone. MySQL can't help you with that. The next problem with schema migrations is discovery. The user, your developers want to change, to add some column to a table, and you may need to first infer which cluster is affected. Where does that table live? And if this cluster is sharded, then you need to identify what are the relevant shards and what are the primary servers on those shards. So where am I going to apply those changes? And MySQL can't help you with that because it doesn't know, what your shards are called or how you organize your data. But Vitess can, because Vitess has that kind of information. Next thing you want to do is to run your migration, and then be able to throttle migration based on your production workload. Again, MySQL can't help you with that. If you want to throttle by lag, MySQL doesn't understand your topology. It doesn't understand that in this cluster you have this and that many replicas, and some of them may lag, but MySQL doesn't have that essence of there are a few servers lagging in this cluster. It just doesn't speak cluster scope, but Vitess does. Vitess does know what servers exist in each topology. But moreover, some of these servers may be, your normal replicas, but others may be like backup servers or all-up servers or development machines, and you don't really care if they lag. So again, this is the kind of information that is like meta information to MySQL, but not for Vitess. Vitess is aware of that kind of information. Next is getting visibility into the random migrations. Do you need to SSH somewhere to get information about the status? Is it running? Is it successful? Is it failed? How do you control migrations? Are you able to terminate a running migration? And so there's many problems, and Vitess is in this unique position that, thanks to its architecture, it has literally all the knowledge necessary to be able to automate away and to alleviate the problems which I've described. And this is why Vitess is able to give you this query. So alter with gh-ost table orders, add column TS timestamp. And that's what you will now run on Vitess. The syntax itself is still subject to change as this feature is experimental, but this is how it's going to look in general. And this is like a hands-free zero dependencies thing. It's not a real trademark. It's not really a registered mark. And we're going to drill down into what does it really mean to have zero dependencies. So you can run migrations with gh-ost. You can run migrations with PD online schema change. Both are fully supported by Vitess. Let's do a quick demo to illustrate. So in this demo, I log in to Vitess. Please note that while I use a standard MySQL client, I'm not logged into a real MySQL server, but instead I'm connecting to Vitigate, which, as we mentioned, impersonates to be a database server. So we have this table eggs. It's just a normal table. It's populated with a few rows. And one column to note is ID, which is a big int, unsigned. The first thing I'm going to do is run just this normal alter table. So I'm going to modify ID to be just a normal int. And we all know this is a blocking operation. But a few notable things is that I show create table, right? I run the alter table. It says I'm complete. I show create table. And indeed, we can see that ID has been modified. Now, it's worth pointing out that Vitess came in useful at this stage already. Even though the migration was blocking, Vitess was able to identify the backend servers where that contain this table. Now, I should mention that this table is actually sharded across 4 different clusters. And Vitess was able to say, okay, table X is on those 4 clusters. And these are the primary servers on each cluster. And so this is where I'm going to run this migration on your behalf. So it's already very useful. But of course, the alter table is still blocking on each of these clusters. And so our next step is to run an alter with gh-ost table X. And we're going to modify ID into a big int again. One thing to notice is that the response to our alter table is this strange UUID. We'll get back to that value later. Essentially, it's a job ID, which we can later use to track and control the migration. And the next thing we do is to show create table X, but ID is still int. It hasn't changed into big int as yet. That's because the migration is online. It's asynchronous. It will run eventually on all 4 shards, but each will schedule it to run in its own good time at some point in the future. We show create table again. No, the schema hasn't changed. Let's try again. All right, there it is. The schema has changed. We've migrated this table with gh-ost. ID is now big int. The data is still intact. And we'll get back to this demo later, but let's see what just happened. And if this demo was underwhelming to you, then we've done our job right. Behind the scenes, things are quite complex. So we were connected to Vitigate and we ran this alter with gh-ost table, modify something. Vitigate intercepted our query. It saw that this was in fact a very special alter table. This was a gh-ost, an online DDL migration. It decided not to push this statement to the backend servers, to the database servers, and instead persist a request for online DDL in global topo. And so that's all. They just wrote something in key value. Later on, VD control daemon periodically checks for new requests. And it saw our request and said, okay, now it is time for me to look into that request. It parses the query. It looks into the schema and table involved. It infers what clusters and what shards are involved. It identifies which are the primaries for those shards. And it pushes the request, not the query, but the request for the migration. It asks the tablets, the primary tablets, to persist those requests, and it validates that all of them have acknowledged receipt of that request. And now that's where all the fun takes place. VD tablet on the primary prepares the scripts. It schedules the migration. It runs the migration in its own good time. It makes the choice on when to run the migration. So it prepares the scripts, it runs gh-ost or PD on schema chains, it tracks the runtime, it throttles as needed, it cleans up after completion, and it also stores the state in a VD meta in a table called Schema Migrations in a VD meta schema on the clusters themselves. So we will break that down a little bit further shortly. Let's meanwhile continue the demo. If you remember, we left off at the time where the table was modified and everyone is happy. Now you will remember that we just ran show create table, show create table, show create table until we noted the change. Of course, this is far from ideal. We will now run VDCDL, so that's the VDCDL client, to look at the status of migrations on our schema. And I'm going to zoom out, and don't worry if your screen resolution or the video doesn't look too good in this presentation, because you'll be able to easily run this demo on your local machine later on. I'll provide the link. So I'm looking at all the migration history, and I notice there's 4 rows. And there's 4 rows because we have actually 4 shards to this table. And this is the migration UUID that we saw earlier. We can see that the migrations were run with gh-ost. They started at this timestamp, ended at this timestamp. They were successfully complete. Cool. The next thing I want to show off are 2 features at the same time. So we're going to run another migration, this time with command line arguments. So we're going to provide extra arguments to gh-ost. We will run gh-ost with max load equals threads running 1, which is a funny thing to do. We're going to shoot ourselves in the foot because gh-ost itself uses a thread for MySQL, so this migration will throttle forever. It will never complete, right? We can show create table all we want, and the migration will still be running. It will never cut over. So let's zoom out again. Let's go and see, look at VDCDL and see what it has to tell us. So we're again listing all known migrations, all migration history. This time there's 8 rows. There's our 4 completed migrations and now the 4 running migrations. There's a little bit noise, so we will now filter using only our UUID. So I'm only showing by our UUID, and that's how we can see just our 4 running migrations. Now, between you and me, we know that these migrations are not going to ever complete. So like 3 weeks later, we give up, like something is clearly not working. We are able to actually cancel those migrations. And so to cancel a migration means we want to abort it. If the migration never started, it will not be started. If the migration was already running, as such was our case, it will be hard terminated. It will transition into a failed state. The next thing is that we can actually retry a failed migration or one that we have canceled. So we can ask the migration to run again. Perhaps it failed on real reasons, not for reasons where we chose to shoot ourselves in the foot. And so you will notice that VD tablets have queued these migrations to run, and they will run them in their own good time. Again, between you and me, we know that these migrations will never complete yet again because they still again run with thread run max load equals threads running 1. All right, zero dependencies. What does it really mean to run zero dependencies? And this will take, give us a more in-depth look into the operation. So there's a lot of things you need to do to run an online schema migration, right? You need to create a MySQL account, like for gh-ost or for PDL schema change, and give it the proper privileges. You don't need to do that with Vitess Online DDL. VD Tablet will actually create a special account on your behalf with a random password for each migration and will destroy this account when the migration completes. There's nothing you need to do. If you run Ghost runs with hooks like report status or whatever. What do you need to do to make that happen? Well, nothing. Vitess creates a temporary directory where it runs your migration. It will populate it with the necessary scripts or hooks for Ghost, and it will just instruct Ghost to use those scripts. So there's nothing you need to do. Well, how about Ghost itself, the binary? I mean, which version do you need? If you run on AMD 64 recent glibc, you're in good shape, and you actually don't need to do anything because Vitess comes with Ghost precompiled. Ghost is actually precompiled and embedded within the VD-tablet binary. When VD-tablet starts, it self-extracts Ghost and puts it on your file system. You actually don't need to do anything. It will just put Ghost and make it executable and run it. Now, if you do need a special version of Ghost, you can configure VD-tablet with -ghost path to indicate where Ghost is. And if you want to run PD on schema change, that's fine and well supported, but Vitess does not bundle PD on schema change. You'll have to install PD on schema change on your MySQL servers along with all pair dependencies like DBI, libdbi, and libdbdbi MySQL. How do we configure the throttling replicas? So you want the migration to throttle, but only according to the relevant replicas. The good news is that Vitess has all this kind of meta information. It knows which replicas should serve traffic and which replicas shouldn't serve traffic. It will actually run a throttler service. It's forked from GitHub's Freno, so each VD tablet or the primary VD tablet runs a throttler service which self-updates with the current roster of servers. And Ghost is configured to automatically consult this throttler service, and Vitess creates a plugin and instructs PD schema change to use that plugin, which checks that throttler. So again, you don't need to do anything. Throttling just happens. How about a PD on a schema change migration that fails, and we have those leftover triggers, which are a disaster for our performance. So good news is that Vitess will take care of those. When the migration completes, Vitess will make sure whether successful or fail. It will just make sure that the triggers are dropped. In fact, VD tablet itself can fail, and still Vitess will figure things out and drop the triggers. You don't need to do anything. And last, how about those leftover tables? So as you know, PD on schema change and Ghost, they don't really operate on your real table. They create a Ghost table, a shadow table, and then populate that. And at the end of the migration, they rename your original table away into that huge table now unused, which just lurks there. And we know that dropping tables in production can in itself be a risky operation. And I can spend 30 minutes just on that, but Vitess now includes a table lifecycle mechanism where the table is renamed away and then being purged, slowly purged, using a throttler, depending on a throttling mechanism, and then finally silently and conveniently dropped away. So this is already integrated into the online DDL flow, and you do not need to do anything. It's time for our mystery card reveal. In between the time that I started discussing online DDL to this point, there's a hidden truth, and that hidden truth lies within something I didn't say. Throughout this presentation or the discussion on online DDL, I did not discuss getting Vitess to run your production traffic. Vitess can run your online DDL without you moving your production traffic through Vitess. You can just put Vitess on top of your existing clusters. You can keep query your databases as usual and just use Vitess to run your database infrastructure. Use Vitess as an infrastructure framework. So you can get schema migrations, you can get throttling, you can get table lifecycles and failovers coming shortly. You can run all these just as infrastructure, and you don't have to go the full commitment with Vitess. And so we know that installing Vitess is still an undertaking, right? There's a lot of moving parts. And we are working both to make that a more lightweight process, as well as incorporate so much more infrastructure framework into Vitess that it will be worthwhile for you to set up Vitess, whether you want to run traffic through Vitess or not. I'd like to acknowledge a few teams. I'd like to acknowledge GitHub and the GitHub Database Infrastructure team, which was my previous gig, where we developed Freno and Ghost and a lot of automation, and where I got so much production insight and lessons learned, which I incorporate here. I'd like to acknowledge Percona for Percona Toolkit and PD Only Schema Change, and the community and maintainers and the Planetscale team for engaging and reviewing and giving feedback and acknowledging and pointing out. So thanks everyone for your help. Some resources, there are docs, please read the docs. The code is of course free and public on GitHub. We do run a Slack channel. It's vitess.slack.com. Anyone can join, where you may ask questions and we will try to answer our best. And if you would like to run the demo, that's pretty simple. Just install a schema and run this command line. And with that, I would like to again thank you for tuning in and wish you all the best of health, in the hope that we all just transition through this year of 2020 into 2021 and beyond in good health. And at this time, I am open for questions. Please.